Hi, so today we have this delightfully expensive piece of lab equipment to look at. This is a Fluidigm Polaris system which is designed to extract cells from a sample and then treat them with a number of different drugs or chemicals to see the effect of those chemicals on the cells. I think it does about 48 experiments in parallel. But the first thing you really notice about this is just the Apple level sort of aesthetic wankery of this. We've got this all black enclosure. These covers are aluminium. These have been machined out of 10mm aluminium plates with this sort of organic pattern machined into them. These side panels weigh about 8.5 kilos each. The whole thing weighs 110 kilos. So it was a bit of a struggle getting this thing in and up onto the table. In 2015, this cost $400,000. The last test date on this is September 2018. Looking at the history of the runs that this has had, it seems to have been sort of used like for a few days every so often between about 2015 and 2017. There's only 48 runs in total now. I don't know if that's all it's ever been used for, but certainly looking at the dates, yeah, over the last sort of couple of years it was being used. It was literally sort of 2 or 3 times a year, so this has not had a great deal of use. When I got it, the PC wasn't booting. This runs Windows 8 embedded, and that was simply a faulty memory module. I just literally pulled one module out and it booted straight up. There was also a mechanical issue in that this tray was jamming when it was coming out, and that was down to a screw seemed to have got dropped in there somewhere. I'm not quite sure. That's possibly might have been when I was doing some initial disassembly, but I don't think so. I don't recognise the screw when I got it out, but so it was going halfway out and then making a nasty graunching noise. This monitor, say there's a fully custom monitor case, there's a sort of tilt mount on it, but this monitor looks like it's been again machined out of a solid block to make this enclosure. We've got this glass front on here and sort of glass on the monitor and also on front of the sample drawer that comes out. We've got this nice sort of illuminated touch on-off button. And just to add a further little bit of wankery, there's actually a row of these purple LEDs. They're actually white LEDs through a very dark purple filter designed to match the sort of the corporate colours, which, I mean, you can't see these at all during daylight. You'd only see them in the dark, and they sort of throb up and down in a very designery sort of way. Again, why? You know, are people buying very niche biotech stuff going to be swayed to make a decision because of the way this thing looks, or maybe it's because just to give them a warm fuzzy feeling for the amount of money they've just spent on this. The Fluidigm is now called Standard BioTools, and looking through their product range, it looks like there's only a couple of products that have got this sort of styling. The rest of their stuff seems to be sort of fairly normal. So I don't know, maybe they had a particularly excitable product designer that wanted to go all Apple on this, and then they decided it wasn't really worth the money. It powers up, we get some very fancy looking designer graphics going on. I wonder how much they paid someone to come up with these graphics. The user interface is actually sort of very simple. There's sort of the basic menu, a very sort of locked down menu system, so we can look at previous runs. Quite a lot of these sort of seem to be sort of to do with installation and testing rather than actual runs. But we can then go in and look at them, and we can actually see some of the images that have been produced. So there's some images there, and we can adjust the contrast. This is a map of the microfluidic plate. Unusually for this sort of thing, I've actually got some of the consumables, and these are these amazing microfluidic things. I think I might leave these for a separate video, but basically you've got a load of wells here that you put samples in. It uses compressed air to sort of push the samples through, and then they go into this central area, which is I've got all sorts of interesting channels, and there's actually sort of valves and all sorts of stuff in here. There's quite a few different versions of this. This one is specific to this machine, but they do a whole load of other ones for other machines for all sorts of different purposes. Like there's one that's got like a big matrix, so you can have sort of one set of chemicals going in one way, another set the other way, and you do like an X times Y reactions between those two different sets of chemicals. I saw about 20 odd different versions of these in a catalogue. These ones I think are about $1,000 each. And I think they're single use. I'm not sure. It may be possible to flush them out and reuse them, I don't know, but they're very limited use, if not actually single use, but so I think I'll maybe leave the details of this for another video. This mode here, this is for calibrating. As with a lot of these things, you use special stains to indicate sort of the chemical actions that have happened, so they're lit with a specific wavelength of light and then they look through a narrowband filter to see the fluorescence of that. And this is actually for calibrating those stains. Now I have actually managed to get this to work once, but it's been a bit flaky, so we can open up the tray and it sort of appears very slowly. When I originally got it, it was sort of stopping halfway and making a nasty grinding noise, but so once I removed the errant screw that's in there, it glides quite nicely. There's this sort of platform here which has got a Peltier cooler element on it, and there's also a few little holes in there, so it uses vacuum to hold the sample down. There's this interface plate which has basically got silicone gaskets on both sides, and there's a window here with a temperature humidity sensor, and this is actually a heated window. This is an ITO glass window, so it can actually heat it for to avoid any condensation. Plate goes on here, then this whole thing drops in and then it slides in. This is the plate for the hebocytometer thing. All I've done is I've put a piece of paper in here with a few different fluorescent highlighter pens just to see if we can get any fluorescent stuff going on. That then gets sort of loaded into the tray, and then we can read the barcode. It uses vacuum to suck it down and also uses that for detection. I found I actually had to push the Peltier up slightly just to get it to grip. I think there might be perhaps a silicone gasket or something that's meant to go in there to help seal it. So if we do read barcode, it sucks it on. When it pushes in red light, it's reading the barcodes on it. So now we can load it. It shuts the door behind it. I'm getting an error. I have had this work once. I managed to save a few images from it, but something's clearly not working now, so give up on that. The main menu just gives you basically three options for different types of experiments to run: extracting and dosing cells, seeing what they do over time, and also no treatment, which is just extracting the cells, nothing else. And there's sort of various parameters that you can sort of set. Nothing hugely interesting. Surprisingly, the manual for this is only like about 60 pages. Seems to be a very, very niche, very specific type of process this is designed to run. So this is a completely custom monitor housing, and I'd imagine they probably ship the monitor separately, so there's a couple of sort of release screws. And you think sort of why not just supply just a standard monitor with the VESA mount or something, but no, they've sort of gone full on custom on this thing. And so if we just undo those screws, this monitor comes off to reveal this sort of complete custom mounting system. So we've got these big sort of alignment pegs and a sort of central connector here, and that mates with this connector here. All sort of, there's a air vent here with a filter behind it, so the air is sort of vented out behind the monitor. The funny thing is, this sort of super fancy monitor, this is actually using an analog VGA type interface. It's not even digital. And so here are the LEDs, and quite amusingly, when I took this apart, the paper that protects this acrylic was actually still on there. So whoever was using this probably didn't even get the benefit. These wanky purple throbbing LEDs, because the paper was still over it. And there's this sort of metal screw down plate that then reveals the sort of buttons that you normally find on the front of a monitor. And inside here we've got what is obviously a bog standard off-the-shelf monitor. That's probably an OEM one designed for integration, but just with a normal controller board, VGA connector in. Don't know what the actual resolution of this is. The only custom parts are this rear board. This is a 3.2mm thick board, which has got the connectors to mate with the one on the main unit. The board of throbbing LEDs, which are just normal white LEDs, but behind this very dark purple acrylic filter. And it looks like there's just a current regulator on here, so the sort of throbbing effect is clearly done on the main unit somewhere. And we see the construction of these covers. We've got this sort of the textured side plate. There's a separate corner piece here, sort of stiffening ribs, and I mean they've even engraved the part number into the surface of it. One thing that's noticeable is that the build quality was excellent. Yeah, all the cables have got these nice sort of labels, everything is all nicely tied down. You'll see a few missing screws and loose cables, but that's just because I've taken some stuff apart for some initial investigation, so it was extremely tidy when I got it. So down here we've got the compressor that supplies the air supply for the sort of squirting the stuff through the microfluidics. We've got a great big manifold here with all sorts of pneumatic valves and pressure sensors on it. Got a control board down here, some more sort of more pipes. Incidentally, all the pipework in there is just for air. All the reagents are actually put onto the fluidic plate and they're just blown through. There's a little vacuum pump there, which I think is just for sucking the plate down onto the Peltier cooler. You see the edge of another great big manifold with loads and loads of pneumatic valves down here. So this is a light source. This supplies, I think it's 5 different wavelengths, outputs through this fibre optic output coupler. And there's a second fibre here. I think that might be a feedback thing for it to regulate the light output. This is made by a company called Lumen Dynamics, who do a lot of sort of custom illumination type products. Massive great power supply that goes all the way down here. At the top, this is the camera. This is made by a company called Finger Lake Instrumentation, who specialise in scientific cameras. There's a big heatsink on the side, so it's probably a cooled CCD. Over this side, we've got the PC. This is a Contron industrial PC motherboard. Loads of USB connections. I think pretty much every USB port on this board is used, either internally or for the external connectors. There's a 1 terabyte SSD. Down here we've got 3 air filter dryer units. So those tiny little microfluidic channels, only like a small amount of dust would easily block those. Got another PCB down here with loads of wires going all over the place. There's a motor in here. This is the one I think which raises and lowers the front door. And there's the optics assembly we can only see part of, and there's these sort of soft mounts. This whole thing is sort of mounted on like a shock mount type thing. This circular bit, I think this is probably going to be a wheel for various narrowband filters. And there's a couple of big tanks on there which are the reservoir for the compressed air. And the tray assembly, so there's this Peltier block which has got small holes in it for vacuum pull down, and this actually just lifts out. You see the heatsink on there and some wires and the vacuum tube going into it. And these slight mystery brackets here, they don't actually seem to sort of hold anything in. I wonder if those are maybe sort of from some sort of service procedure for holding something in place for alignment or something, but they don't actually seem to serve any function as far as I can tell. Let's take a look at this first pneumatic block, the sort of massive block of acrylic with various valves going onto it. And this side we've got PCB. There's what look like 4 unused pressure sensors here, so this may be designed for multiple products. USB connection, FTDI chip here. There's a PIC controller here, can't quite read the number because it's got conformal coating on it. A number of various valves, I think it might be some pressure regulators as well. These are all Norgren branded. This whole assembly I think is custom made by Norgren for Fluidigm. And with that out of the way, we can see the fibre optic output from the light source. I think there's 3 optics here which probably just go to illuminate different, from different sides to get even illumination. And there's the second one here which I think is going to be a optical feedback. Yeah, so this is the output thing. Looks like it's got some mirrors or stuff going on inside there. So maybe some sort of beam splitter mirror to divert the output to these 3 different fibre outputs. I'm assuming these are fibre. I have actually come across in the past things that look like fibre cables, but they're actually liquid-filled tubes. Around the back here we have a power distribution board, nothing particularly exciting there, 12 and 24 volt in from the power supply, and then just power out to all the various different modules in the system. Alright, so this is the door assembly. Pretty much all this whole assembly does is run these 2 motors which are like a rack and pinion to open and close the door. So this one lifts it up in position, and then the second one sort of pushes it flat, flush with the front. So that's it closed, it tilts the bottom in, and this bottom motor pushes it down. That's most of what this board here is doing. An FTDI USB serial chip, MSP430 processor, a couple of motor drivers. The only other things this does, this interfaces with that sort of wanky illuminated touch button on the front, and that's actually an off-the-shelf product made by rapidkeypads.com, or either an off-the-shelf or a custom-made thing for them, which has just got a sort of bunch of LEDs that shine into a piece of acrylic to provide the backlighting, and there's a touch sensor there. This thing interfaces with a read relay here. This goes to the PC's on-off control button, And the only other thing this does is interface with those wank LEDs on the front. Interesting, it looks like there's 3 channels, so maybe they were originally planning to do RGB, and then figured out they couldn't get quite the right shade of purple with RGB, so they went for white with that filter on it. You can now see a bit more of what's going on here. So we've got this optics assembly with this amazingly complicated looking adjustment thing. I assume this is just for precision alignment of the camera. There's this sort of big optical block with these convenient handles on the side. This whole thing is on a floating vibration mount. Here, this is one of the optical feeds. There's another one that goes around the back. There's a little built board here with some pogo pins. These connect to this unit here when it's fully engaged and in the slot. So this provides power for the heater and the temperature humidity sensing. On the bottom here you can see a couple of pneumatic cylinders. So I think maybe those are for like clamping the heating block up against the fluid cell thing. So we need to get in a little bit further to see what those are actually doing. Okay, over here we've got some stuff dealing with the air ports on the back. There's 2 ports on the back, one for external compressed air and the other one for, I think it just says pre-mixed gas. I presume there's some experiments need to be done under inert gas or some other condition. And here we can see there's just a couple of tanks here acting as a pressure reservoir. Another one of these filter units. I think this wool in the bottom is probably just for to soak up any condensation that you get on these. This is the PC board, nothing's particularly exciting, made by Contron, specialised in sort of industrial embedded PCs. It's got the sort of things you quite often find on industrial boards, like sort of RS-232 ports and some general I/O expansion, but other than that it's nothing particularly special. There's not a huge amount on the disk on this, so it's Windows 8 embedded, which as far as I can see is sort of basically Windows but with no desktop. There's still a few familiar things in there like File Explorer that you can get into. The software, there's a couple of bits of software that I couldn't get access to, which are password protected, which I think might be for maintenance. A lot of the main application seems to be driven by sort of scripts describing, sort of the various operations to do for each of the menu items. There's a few images on there, but as I saw earlier, it doesn't seem to have had a huge amount of use. Look at this camera. Wow, look at that sensor. Some of the images I found on the disk were 5168 by 5168, so that's maybe a square crop of this. This is about 50 by 40 millimeters. Some spec I found online says it's a 6 micron pixel pitch, so this is pretty huge. We're going to definitely have to have a play around with this. It does look like there's drivers and test software and so on the disk, so hopefully you can get this fired up. It's a USB interface, big heatsink there, so it's probably cooled. Made by Finger Lakes Instrumentation. I had a quick look on their website. There wasn't anything anywhere nearly as big as this, so this is probably a custom job. Tripod mount on there. Very impressive bit of image censoring. Right, this little PCB assembly which was down the left hand side, this seems to be just concerned with interfacing to this. It connects to the pogo pins to make contact with this. There's also a little tube that contacts here, which I think this is vacuum sensing to detect when this is in place, and maybe also when this is in contact with the microfluidic cell. There's a pressure sensor, the valve here, so I think it just applies a vacuum via this valve and measures the pressure to detect when it's making contact. Interesting, the processors on this subboard, MSP430, they seem to like the MSP430, all the Fluidigm boards seem to use it with a FTDI USB serial interface. Interesting, there's a second USB serial interface on here and a couple of opto-isolators, so I can only assume this is some sort of maintenance or auxiliary sort of control or something. There wasn't anything plugged into this USB port, so a little bit odd they'd have it's on a little carrier PCB. Actually, I think these are going to be the drivers for the heater in here. See, the sort of the flex is bonded to the glass, so this is ITO, Indian tin oxide glass, so the glass itself is heated. I think there's also heaters down the side to control the temperature in this area, and so there's a temperature and humidity sensor here. Okay, the tray assembly was a bit of a fiddle to get out, so I just pulled all the bits apart. At the front we've got a little USB webcam. This is for reading the barcodes. There's a little illuminator board in there with some red LEDs. This is the Peltier, the actual sort of Peltier assembly. It looks like it's a multi-stage unit, because you can see there's a sort of two fairly thick wires going in here, but there's also flex connections going up into here. And this is the board that it's all plugged into. This was actually on the underside of the slide out assembly, and there's an enormous amount of stuff on here for what appears to basically be just controlling some Peltier elements. There's sort of tons of power stuff here, two great big ones. These big ones are probably running the main cooler, and then perhaps there's one or two sub coolers. But there's, what I don't understand, there's lots of isolation. There's these analog devices, digital isolators. There's sort of 5 on that side, another 4 on that side. Seems overkill. I mean, I'm not quite sure why you'd need to isolate this, because obviously presumably it could be grounded for safety. But they seem to have got a ridiculous amount of components on here for what is basically controlling a few Peltier coolers. Again, it's a USB interface, FTDI chip and MSP430 controlling it all. Cooler NTC, that's obviously temperature sensing. There's also a temperature sensor sensing the temperature of the whole plate. Rather bizarre. And even these sections here, there's an awful lot of whatever these stages are. This actually looks like there's 6 stages. The connector does a thermal stack, which implies there's more than one. But it looks like we've got sort of 6 completely separate stages here. I wonder if maybe these are actually separate zones. That would probably make sense. I'm looking at this, there are some distinct different areas here. It would probably make sense if it was possible to control each of these to a different temperature. So that would possibly explain why this is so complex. We've got like one sort of big Peltier just pumping all the waste heat from the top section. And then we've got all these flexes running multi-section, so they can actually individually control the temperature of each section. That would certainly explain why it's so complex. See these sort of lines between them. I initially thought these were just to sort of distribute the vacuum, but I think these might actually be thermal isolation. Yeah, delving deeper into this, that looks like what's going on. We've got a total of 12 pins down here soldered onto the flex. So there's going to be Peltiers and presumably temperature sensing on each of these segments. This whole lot seems to be sort of pretty glued together, so I can't easily get it apart. But right, I figured out why they've put handles on here. This optical assembly is immensely heavy. There's no way this is aluminium. This has got to be something very heavy for stability. So it's on this sort of anti-vibration mount. I can barely lift this, so there's definitely something interesting going on. Right, this PCB, which was down in this corner, seems to be mostly to do with motor drives. It drives the motor that runs the sled backwards and forwards. There's quite a lot of limit switches, and I think this is also what handles the moving up of the whole sample thing up to where the camera is. And if we look in here, we can see this sort of assembly which pushes the whole assembly upwards to sort of clamp it up against the face where the camera looks at it, and probably also seals all the pneumatic stuff. There's two big square pneumatic cylinders here. There's also, I think these might be small pneumatic cylinders, and as usual we've got a big modular power supply in here. One of these 12 volts is used to run the compressor. They actually use the enable input to turn the compressor on and off. It does seem quite a lot. Okay, there's a few Peltier coolers and a PC in there, but does seem a little bit excessive. After a considerable amount of wrangling, I've finally managed to separate the optical block from the rest of the unit. So this has the sort of camera mount here on the right, and then there's a filter wheel, number of filters, with a comically huge stepper motor driving it, and just some very expensive looking lenses going down to the to image the Fluidigm bit. I don't know what this is made of, but it's sort of not quite soft enough to be lead. It's not magnetic, so I don't think it's cast iron, but I mean this whole assembly is probably a good 10-12 kilos. A very elaborate set of mechanisms here. Now I'm pretty sure these are just to basically adjust the position of the plate in respect to the camera and also tilt it. So we've got sort of 2 motors acting in this direction. There's one here that sort of, I think there's a screw thread making it go this way. There's another one here, so I think this one and the two vertical ones give you your sort of tilt adjustment. Actually no, this one here, this is actually the one that pulls the sled in and out. Set of 3 motors that sort of give it its adjustment to actually get it completely flat, to get a nice clean sort of focus plane in the camera. Somewhat elaborate set of sort of linkages. Let's look at this mechanical assembly. This is the bottom bit which sits underneath the optics. Interface plate and the microfluidic plate sort of sit in sort of like there, and then these two cylinders push up here to sort of clamp it into place at the top. Now there's 4 little cylinders here, and these just poke little pins through. These actuate various parts on the plate. There's these 2 here which I think are sort of pressure release valve or something, and the other 2 press against here, which is just to basically push this down to release, because this is silicone so this could stick. So these are just like 2 release pushing pins to push this down away from here. Now where this gets really interesting is if you look at what this thing is actually pushing it up against. And that is this completely insane looking manifold block. Again, I think like the other one, this is done by diffusion bonding, but this is just ridiculous. Funneling all these pathways down to the holes that match up with the various different sections of this, which in turn go through to this, which can in turn go through the holes into this unit, and then goes down these tiny little channels until they hit this central fluidics bit. And on this side we've got rather a lot of valves feeding all this stuff. So there's a bunch of valves directly on the manifold there, another bunch at the back, a load of driver boards. Right, seem to be 2 different types of valves on here. There's Microsol and Picosol. I'm guessing those are the Norgran brand names for the valves. These driver boards are pretty straightforward. This one is 74HC595s and presumably dual MOSFETs driving each one. It's like a little spade connector. Push on tabs for this, and for these smaller ones up here, these have got again 595s and also drivers that marked DRV104, and that's a current regulated low side driver from TI. One thing I find really surprising though, the connections to these small solenoid valves are just sort of these push on 2 pins, and there's no positive locking. You know, almost all these connectors have got some sort of positive latching, but for something like this where you know you might have some vibration, they're just push on connectors. I thought that's, for like, you know, an industrial manufacturer to not have some sort of positive lock on that connector is really unusual. So this is the manifold in all its glory. I mean, this is just magnificent. 42 valves, these little ones, 16 of these larger ones. Various sort of ports to carry the air, presumably regulated at different pressures. A couple of exhaust ports there with like a sintered plug in them. Basically these all just come out a few layers. You can actually see some sort of trace of layering. As I said before, this is almost certainly made using diffusion bonding. Multiple layers of acrylic that are machined and then sandwiched and cooked to bond it all together. So basically these seem to be in sort of groups, so there's like little sort of 3 independent 3x3 groups here, and then there's a few odd other random ones. They match up with the holes, these holes here, and the odd ones sort of dotted around go to these channels. So these sort of inject simultaneously into all of these, whereas the ones here are sort of individual. Again, I'll probably do another video just looking into this in more detail, because there's just sort of so much going on this thing. But I mean, this is just a magnificent thing. And look at the way these go on. There's sort of 2 alignment pins, then there's a little gasket and 3 ports on here, so these are a changeover thing. One thing that does strike me though, if you've got all these valves all nicely lined up with sort of pins like that, why would you do all this spaghetti stuff when you could just stick a PCB on here and have these just plug straight into contacts on a PCB? That would be much neater. If you've gone to all the effort to make something like that and then just can't be asked to design a PCB that just plugs on there neatly, I really don't understand. Clearly the pneumatics department are playing a much better game than the electronics department in Norgran. I mean, if you did it on, say, some 3.2mm PCB, you could probably get rid of all these brackets as well. Literally, the PCB could be holding these down and making all the connections all in one go. It's just ridiculous. Okay, so I think I'm going to leave the camera and the light source for a second video because there's already been quite a lot on this. But there's just so much stuff in this machine. There's these crazy manifolds, and like some of the machining, you've got this piece here. Literally, sort of by adding these sort of pieces at the end, they've sort of pretty much doubled the size of the block this had to be machined out of. And then there's sort of more huge amounts of machining going on here. Probably one more video for the optic stuff, maybe another one after that for the microfluidics.